We will continue the discussion from the previous video and understand ordinal and nominal variables. First, we will understand ordinal data. While clustering, you will come across variables where the data is ordered. Examples of such variables could be preference of car brand among the car buyers or ranking of desserts among the survey takers. Such variables that have a ranking or some kind of order are called ordinal variables. One thing to understand is that the difference between the various responses in ordinal variables cannot be shown in numeric terms. So for instance, a car buyer might rate Maruti as the first preference, Honda as second, and Hyundai as third. It is not possible to present these rankings numerically. In other words, there is no way to make sure that for a particular customer, the difference between Maruti and Honda is the same as the difference between Honda and Hyundai. The ranking or order is only giving us this much information that one option is more preferable than the other. Let's now move to the nominal variable. Think of this variable as an extension of binary variable. Only this time, the variables would have more than two responses. If you recall, symmetric binary has only two possible responses and both of them carry equal weightage. On the other hand, if we have more than two responses that are all equally important, then such data are called nominal variable. So variables like 3 movies you like, list of people you dated, or plantations grown in a region are example of nominal variables. If such variables have two responses, then they are symmetric binary. And if they have more than two responses, they would be called nominal. Let's now move to the next point, which is scaling or standardizing the data for the purpose of clustering. We will also understand when it is appropriate to do this. Suppose the data that needs to be clustered is a combination of variables with different units. In such a scenario, it is considered appropriate to scale or standardize the data for getting best results. For instance, suppose you are clustering the data on the basis of two variables. These variables include the number of dogs owned by a person and the annual income of that person. While both the variables are continuous, the units of these two variables are different from each other. In addition, there is a sizable difference in the responses of these two variables. The response to the first variable, that is the number of dog one owns, would most likely be a number between 0 to 5. On the other hand, the second variable, annual income, would be a relatively large number. It is therefore best to scale or standardize the data in such cases. The most common way used for scaling the data is to subtract the mean of the variable from each of the values in the variable, and then divide the resulting value with the standard deviation of that variable. The resulting value after scaling the data would be between 0 and 1. For data with such variables, you are expected to get better clustering results after following this process. As already explained, this method is the most common one for standardizing the data. In the current context, the word normalizing, standardizing, and scaling are used synonymously. Your main takeaway from this and the previous video is to understand that the data that needs to be clustered would mostly come with mixed variables. The moment you have the data in hand, the first step is to identify the data type of the various variables that are present in the data. Once we understand the type of variables in the data, that is whether they are continuous, binary, ordinal, or nominal, then a suitable method could be applied for clustering the data. Let's revise what we have learned in the past two videos. Continuous variable is the most common data type. Such variables include numeric data such as number of forest fires or number of pizzas that one eats in a month. Next, we looked at binary variables that has two possible responses. Examples include variables such as someone is pregnant or not, or other yes or no responses. We also understood ordinal variables, which are data with some kind of order. The variable in such data typically include rankings or preferences, such as preference of deserts among survey takers. Last kind of variable that we understood was nominal. These variables are extension of symmetric binary variables. Nominal variables have more than 2 possible responses, and they all are equally important. Finally, we learned the process of scaling the data and when it is appropriate to do so. We also understood that scaling can help in achieving better clustering outcomes. From the next video onwards, we are going to look at various ways you can calculate distance between rows in a data for the purpose of clustering.